Look at the device you are holding in your hands right now. Whether it is a smartphone, a laptop, or even a smart refrigerator, you are staring at a miracle of modern engineering that is essentially a very fast rock we have tricked into thinking. But how do we talk to a rock? How do we tell a collection of silicon and copper to display a cat video, calculate a rocket trajectory, or process a bank transaction? The answer is a deep, layered, and incredibly diverse world of programming languages. These are the bridges between human thought and machine action. Some are elegant and poetic, others are clunky and ancient, and a few are so difficult to understand they feel like a psychological experiment. Today, we are embarking on a journey through the entire landscape of coding. We are explaining every major type of programming language in detail. Whether you are a seasoned developer looking for a refresher or someone who thinks Java is just a type of coffee, get ready. We are stripping away the jargon and looking at the DNA of the digital world. To understand where we are, we have to start at the absolute bottom. Imagine you are standing in the basement of a skyscraper. This is machine code. This is the language of the CPU itself. It consists entirely of ones and zeros. It is the raw, binary pulse of electricity. Humans almost never write in machine code because it is impossible for our brains to track millions of binary digits without making a mistake. Just above that, we have assembly language. Assembly is a low-level language that uses short mnemonics like MOV, ADD, or push to represent specific machine instructions. It is incredibly fast because it has a one-to-one relationship with the hardware, but it is also incredibly tedious. Writing a simple program in assembly is like trying to build a house by individually placing every single grain of sand in a brick. It gives you total control, but it takes an eternity. This brings us to the first major revolution in computing, the high-level languages. We have to talk about Fortran. Developed in the 1950s, Fortran stands for Formula Translation. It was the first language that allowed scientists and engineers to write code using mathematical formulas instead of cryptic machine instructions. It was a massive leap forward. Even today, decades later, Fortran is still used in high-performance computing for weather forecasting and fluid dynamics because it is exceptionally good at crunching numbers. It is the grandfather of the coding world, still working in the background of secret laboratories. Around the same time, another giant was born, COBOL. If Fortran was for the scientists, COBOL was for the businessmen. Standing for Common Business-Oriented Language, it was designed to look as much like English as possible. It was built for processing large amounts of data, like payrolls and banking transactions. You might think a language from 1959 would be gone by now, but you would be wrong. Global financial systems still run on billions of lines of COBOL. It is the invisible skeleton of the banking world. It proves that once a language becomes the foundation of a massive system, it becomes almost impossible to replace. But if we are talking about the foundation of the modern world, we have to talk about C. Developed in the early 1970s at Bell Labs, C is often called the mother of all modern languages. It was designed to be lean, fast, and portable. Before C, if you wrote a program for one computer, it wouldn't work on another. C changed that. Most of the operating systems we use today, like Windows, macOS, and Linux, are written largely in C. It is a mid-level language, meaning it is close enough to the hardware to be fast, but abstract enough for humans to read. However, C is famous for being dangerous. It gives the programmer manual memory management, which is like giving someone a high-powered circular saw without a safety guard. If you make a mistake in C, you can crash the entire system. It is a language that demands respect and absolute precision. In the mid-80s, a developer named Bjarne Stroustrup decided to take C and make it even more powerful by adding objects. This became C++. If C is a scalpel, C++ is a Swiss Army knife equipped with a rocket engine. It introduced object-oriented programming, or OOP. This is a way of organizing code into objects that contain both data and functions. Imagine you are coding a video game. Instead of just writing a list of instructions, you create a player object that has health, speed, and the ability to jump. This makes complex systems much easier to manage. Today, C++ powers everything from high-end video games to the flight software of autonomous vehicles. It is notoriously difficult to learn, but it offers a level of power and performance that few other languages can match. While C and C++ were ruling the world of systems, a new language appeared in the early 90s that would change the face of the internet: Python. Python was created by Guido van Rossum with a simple philosophy: Readability counts. Python looks almost like plain English. It is a high-level, interpreted language, which means you don't have to worry about the computer's hardware at all. You just write what you want to happen. Python is slower than C, but for most tasks, that doesn't matter. What matters is developer speed. Today, Python is the undisputed king of data science, artificial intelligence, and machine learning. Its massive library of tools makes it the go-to choice for researchers. It is the most popular first language for students because it lets you build things quickly without getting bogged down in complex syntax. At the same time, Python was gaining traction. A company called Sun Microsystems released Java. Java's slogan was "Write once, run anywhere." It achieved this by running code on a virtual machine rather than directly on the hardware. This made Java incredibly popular for enterprise applications. If you work at a large corporation, there is a 99% chance they use Java. It is a very verbose language, meaning it takes a lot of lines of code to do simple things, but it is also very safe and stable. Java also became the primary language for Android development for a long time. It is the reliable station wagon of the programming world. Not very flashy, but it will get you where you need to go with a high degree of security. Then, there is the language that people love to hate but can't live without, JavaScript. Despite the name, it has nothing to do with Java. It was created in just 10 days by Brendan Eich for the Netscape browser. Initially, it was just for making buttons change color or creating simple animations on a web page. But then something crazy happened. Browsers got faster, and developers started using JavaScript to build entire applications. With the invention of Node.js, JavaScript moved from the browser to the server. Today, it is the only language that can run on both the front end and the back end of a website. If the internet were a country, JavaScript would be the air everyone breathes. It is messy, it has strange rules, and it allows you to do things that are objectively bad for your code. But it is undeniably the most influential language in the world right now. As the internet grew, people realized that JavaScript's flexibility was also its weakness. Large projects became impossible to manage because nobody knew if a variable was supposed to be a number or a string of text. This led Microsoft to create TypeScript. TypeScript is essentially JavaScript with types added on top. It forces you to be specific. If you say a variable is a number, TypeScript will scream at you if you try to put a word in it. This prevents thousands of bugs before the code even runs. Most modern web developers have moved to TypeScript because it brings a level of sanity to the chaotic world of web development. It is the grown-up version of JavaScript. While the web was evolving, mobile phones were taking over the world. For a long time, if you wanted to write an app for an iPhone, you had to use Objective-C. Objective-C is a strange, older language that looks like a hybrid of C and Smalltalk. It is powerful but has a very steep learning curve. In 2014, Apple decided to fix this by releasing Swift. Swift is everything a modern developer wants. It's fast, it's safe, and it's easy to read. It makes developing apps for the Apple ecosystem a joy rather than a chore. On the other side of the fence, Google did the same thing for Android by promoting Kotlin. Kotlin is a modern language that runs on the Java virtual machine, but is much more concise and expressive than Java. Both Swift and Kotlin show a trend in the industry toward making languages that are both powerful and developer-friendly. But what about the languages that focus on absolute safety? This brings us to Rust. Rust is arguably the most loved language by developers today. It was created by Mozilla to solve the memory safety problems found in C and C++. In Rust, the compiler is incredibly strict. It uses a concept called ownership to track every piece of data in your program. If there is even a tiny chance that a piece of data could be accessed by two parts of the program at the same time in a way that causes a crash, Rust will refuse to compile. It gives you the speed of C with the safety of a high-level language. It is being used to rewrite parts of the Linux kernel and the Windows operating system. Rust is a language for people who are tired of their programs crashing and want to build things that are rock solid. If you like the idea of absolute predictability, you might enjoy functional programming languages like Haskell or Erlang. Most languages we've discussed are imperative, meaning you give the computer a list of steps to follow. Functional languages are more like a series of mathematical functions. They avoid side effects, meaning a function will always return the same result if you give it the same input, and it won't change anything else in the system. Haskell is famous for its extreme mathematical purity, and its legendary difficulty. Erlang, on the other hand, was built by Ericsson for telephone switches. It is designed for concurrency, running thousands of things at once without them interfering with each other. If you've ever used WhatsApp, you've used a system powered by Erlang. These languages are niche, but for certain problems, they are the only correct tool for the job. We also have to mention Go, also known as Golang, created by Google. Go was designed by some of the fathers of the C language. They wanted something that was as fast as C but as easy to use as Python, with a focus on building cloud services. Go is famous for its goroutines, which are lightweight threads that make it incredibly easy to handle thousands of simultaneous connections. It is the language of the cloud. If you use Docker or Kubernetes, you are using software written in Go. It is a minimalist language that values simplicity over complex features. It is the language for the modern era of massive, distributed systems. Then there is PHP. Oh, PHP. It is the language that powers over 70% of the web, including WordPress and Wikipedia. It was created as a simple set of personal homepage tools. For a long time, it was criticized for having a messy design and being insecure. But over the years, PHP has evolved into a very capable, modern language. It stays popular because it is incredibly easy to deploy. You can write a PHP script, upload it to a server, and it just works. It might not be the coolest language in Silicon Valley, but it is the blue-collar worker that keeps a huge portion of the internet running every single day. For the data scientists and statisticians out there, we have R. While Python is a general-purpose language that can do data science, R was built from the ground up for statistics and data visualization. Its syntax is very different from other languages, which can be confusing for traditional programmers. But for a mathematician, it feels like home. It has thousands of packages for every type of statistical test imaginable. It is the language of academia and high-end research. Let's talk about the scripting languages like Ruby and Perl. Ruby, particularly the Ruby on Rails framework, revolutionized web development in the mid-thousands. Its philosophy is developer happiness. It is designed to be elegant and almost poetic. It allowed small teams to build massive websites like GitHub and Airbnb in record time. Perl, on the other hand, is the Swiss Army chainsaw of the programming world. It is incredibly powerful for processing text, but its syntax is so dense and cryptic that it's often joked that Perl is a write-only language. Once you write it, even you won't be able to read it a week later. Perl was the glue that held the early internet together, but it has largely been replaced by Python and Ruby. What about the query languages? SQL, or Structured Query Language, is not a traditional programming language. It is a language for talking to databases. You don't use SQL to build an app. You use it to ask a database questions like, show me all the users who bought a red shirt in October. Every app that stores data, from Instagram to your banking app, uses SQL behind the scenes. It is one of the most important skills a developer can have because data is the lifeblood of modern computing. On the more artistic side, we have languages like Processing and SuperCollider. Processing is based on Java and is designed for visual artists and designers. It makes it incredibly easy to create animations and generative art. SuperCollider is a language for audio synthesis and algorithmic composition. It is used by electronic musicians to create sounds that are impossible with traditional instruments. These languages show that coding isn't just about logic and business. It's also a powerful tool for creative expression. We cannot leave out the esoteric languages, or esolangs. These are languages created as jokes, artistic statements, or puzzles. Take Brainfuck, for example. It consists of only 8 characters, like brackets and dots. It is technically a complete language, but writing the simplest program in it is a massive mental challenge. Then there is Rockstar, a language whose code looks like the lyrics to an 80s power ballad, or Chef, where the code looks like a cooking recipe. These languages aren't practical, but they remind us that at its heart, programming is about the relationship between symbols and meaning. They push the boundaries of what we consider a language to be. We also have low-code and no-code platforms. These aren't exactly languages in the traditional sense, but they are the next step in abstraction. They use visual interfaces to let people build apps without writing a single line of code. They are perfect for small businesses and prototypes. However, they are still built on top of traditional languages. They show that the trend in computing is always toward making technology more accessible to more people. Let's look at the future, Mojo and Zig. Mojo is a new language that claims to be as easy to use as Python, but as fast as C. It is specifically designed for AI hardware. Zig is a modern alternative to C that focuses on absolute control and simplicity without the undefined behavior that makes C so dangerous. These new languages show that even after 70 years, we are still trying to find the perfect balance between human readability and machine performance. So, why are there so many languages? Why can't we just have one? It's because different problems require different tools. You wouldn't use a sledgehammer to fix a watch, and you wouldn't use a screwdriver to build a skyscraper. C is for when you need every ounce of speed. Python is for when you need to analyze data quickly. JavaScript is for making things happen in a browser. Each language represents a set of trade-offs. Some value speed, some value safety, some value developer happiness, and some value being able to run on ancient hardware. The psychological journey of being a programmer is often about learning to speak these different languages. Each one changes the way you think about problems. Learning a functional language like Haskell makes you a better JavaScript developer. Learning C makes you a better Python developer. It's about building a mental toolkit that allows you to look at a problem and say, I know exactly which language is right for this. As we move toward a world driven by artificial intelligence, some people ask if programming languages will become obsolete. Will we just tell an AI what we want in plain English? Maybe, but even then, the AI will be writing the code in one of these languages. The logic remains the same. The need for precise, structured thinking never goes away. Programming languages are the most complex thought tools humans have ever created. They are the artifacts of our attempt to master the machine. Think about the sheer scale of what we've covered. From the binary pulses of machine code to the elegant English-like syntax of Python, and from the enterprise stability of Java to the creative chaos of JavaScript. Every line of code ever written is a tiny piece of a larger story. The story of humanity trying to extend its reach into the digital realm. The next time you open an app or browse a website, think about the layers of languages working together. It is a symphony of logic happening billions of times per second. Whether you want to build the next great video game, analyze the secrets of the universe, or just make a button turn blue on a screen, there is a language waiting for you. It is a world of infinite creativity disguised as mathematics. So don't be intimidated by the jargon or the complex symbols. Pick a language that speaks to you and start building. The rock is waiting for your instructions. The digital world is yours to shape. Thank you for diving into the deep end of the code with me today. Your journey into the heart of the machine is just beginning, and the languages you learn will be the keys to your future. Until next time, keep coding, keep questioning, and keep talking to the rocks. The future is written in these lines of text, and you are the one holding the pen. See you in the next reality we build together.